Hello everyone! In this video, we will take another step toward enhancing the search experience. Let me walk you through what we will accomplish. Here is a preview of how the website will look by the end of the video. Notice anything new? Let me explain. First, I added pagination controls, allowing us to adjust the page size and navigate between pages. Next, I introduced a year filter, enabling us to filter documents based on their publication year. Finally, we will use aggregations to calculate the number of documents per year. Open the project in your favorite editor and go to utils.py. Here, I want to make some small changes. I am no longer printing the cluster info, and I will change max retries to 1 and sleep time by default to 0. We have a lot of work to do in this episode. I prefer to start with calculating the number of documents for each year by using aggregations. For this, I will create a new route that will receive the search query as input and output the documents count per year. Inside the method, we will create a new instance of ElasticSearch. Here, max retries is set to 1 and sleep time is set to 0. I'm intentionally doing this to prevent pausing the program. After that, we will construct our query. And this time, I will use compound queries instead of just leave queries. Because we will be using filters later, this is why I made this change. And I just wanted to use as many things as possible so that we apply the things that we have learned in the first phase. Inside the bool clause, I have a must condition. If this condition is met, I will get documents back. Otherwise, I will get an empty list. Now we can pass this query to the body of the search method. Let's say that we are searching for the Andromeda Galaxy. The search method will try to find those documents. When we get them, we will apply the aggregations, or we will try to compute aggregations. I am giving this name to the aggregations, documents per year, and we are using a date histogram aggregations. This is built into Elasticsearch. Basically, the date histogram aggregations needs a field mapped to a date type. Then I am telling Elasticsearch to group the documents by year, and by default, the group by operation will give me the count of documents per year. Finally, we want the return format to be just the year without the month and days, because we are grouping the data by year. At the end, we are using filter path to return just the aggregations without the other items in the results. We are not done yet. We need to return the aggregations. So here I have a method that will do that. I am calling it extract documents per year, and basically tries to get the aggregations dictionary and convert that into a dictionary where we will have the year and the value is the count of documents. For instance, we could have 2024 and the value will be like 60 documents, 2023, 50 documents, etc. And now we can return this as a response to the frontend to display this in the drop-down component. So let me just collapse this because we don't have a lot of space. Here, everything is good, but I'll try to put everything inside a try and except block because sometimes we might get some exceptions. So it would be great if we can catch them. So let's just return HTML response. The content will be the exception that we catched, and the status code will be 500 to tell the frontend that we have an error. And this will help us investigate what happened. Now, how do we test this? Here I have a good extension that I really like. You can search for it in the extensions store. It's called Thunderbolt. It's this one. Basically, when you install it, you will get this icon. Click on it. Here you can make a new request I already did that. Let me just collapse this so that we get a lot of room to play with. And here, this is what you can do. So here we are going to make a GET request. Why? Because if I go back to the main file, you can see that here, this route is basically a GET request. And here we have localhost. This is basically telling that we are using our laptop. Here API/v1 basically is this route. So now what we can do is that I can copy this, open the Thunder client window, click on new requests, and here I'll again go here, copy this prefix, again click on new requests, put it here, and now I'll copy the endpoint like this. Let me collapse this. Now we need the search query. You can see that here you have query parameters. So I can copy this, paste it here, and set the value to Andromeda, and it will add it automatically to the endpoint. If you want, you can save the requests that you are making. Click on Ctrl S, and by default, you will find it here. If you want, you can put your queries inside a collection. So I can click on these 3 dots, save to collection, and here I already have one, which is called Elasticsearch Course Final Project. Here I'll name this Get Documents Per Year Count, and click on Submit. You can see that here it says saved successfully. Let's close the window, click on Collections, and here they are. Now we are ready to make the request. Click on Send, and here make sure that you have 2 things running. The backend, if you forgot how to do that, basically you need to go to the backend folder and run fastapi dev main.py. And the second thing is Elasticsearch. You need to make sure that the container is running. And as you can see, this is the name that I gave to my aggregations. It's called documents per year. And you can see that this is the format that I was talking about before. You get 2015, here you have the number, etc. Let me search for something new, like Artemis. You can see that here we only have documents up to 2021, which means that this is working. Now we can continue working on the search endpoint. Let's collapse the get documents per year count method because we no longer need it. Now let's go to the top. Here we have the search endpoint. We will add a new query parameter, which is the year. This one should be an optional query parameter. So this is how you do it. Here we make sure that the year is a string value. And here you can see, as you can see, it could be either a string or none, which will tell FastAPI that this is an optional query parameter. Here we have a good structure, but we need to change it because by adding the year, we need to add filters. And we cannot do that with the leaf queries. So we need to change this to use compound queries so that we can mix 2 things, the must clause as well as the filters. So let's start doing this. The first thing that I will change again is this. So I'll change max retries to 1 and sleep time to 0. Here, I'll just copy the query from the get documents per year count method because we will use it. Let's paste that here. So this is the starting point. This is exactly what we did before. We are just searching for related documents by using the multi-match query. Here we are passing the query that we typed in the input text, and we are searching if this exists either in the title or the explanation fields. Now the new thing is that we can add filtering. So let's do it. Because the year parameter can be none, we need to make sure that it isn't. So if year is valid, this means that the user has selected a year. We are going to add a filter. So inside the bool clause, we can add a filter. And here, because we are working with a date field, we are going to use range. And here we are searching for documents that are greater than or less than equal these 2 values. Basically, because we are getting just the year value, we are going to return all documents that are in 2024 or all documents that are in 2023. Basically, the value that the user will select. Now, query can be changed because we already defined it above. From size, these 2 values will stay. And now we need to add another value to filter path because we added the pagination controls. So we need to get the total number of documents so that we can compute the maximum number of pages. This is what we are going to do now. Here I have two methods that I need to paste. Here they are. Basically, the first one will give me the total number of documents. I'm storing this in the total hits variable, and I use calculate max pages to give me the maximum number of pages that we can page through. Finally, we add maximum pages to the dictionary that we return to the front end, but here I made a slight change. Instead of accessing the hits array directly, I am using the get method. Sometimes we might get nothing, and that was causing a lot of issues. So in that case, if we don't find hits, we are just going to return an empty array. Now let's do the same. Open Thunder Client, click on search method, and here we need to add a lot of things. You can see that here we have search query, skip, and limit, but we can add the year. The good thing about this is that if I click on search, we can see that it works because the year parameter is optional. So even if I don't provide it, it still works. And you can see that we get the maximum pages. Now let's add year. Or before I do that, let me go to the other route and let's search for the same term. We used Pluto, and here we can see that we have just one image that was uploaded in 2024. If I search for Pluto and provide 2024, I should get just one document. You can see that here inside this list, if I collapse this, you can see that I basically got just one document and the maximum pages is equal to 1. Let's change this to 2015. So 2015 should give me 2 max pages, or max pages should be equal to 2. Let's collapse this, and voila, you can see that this is actually working. Awesome. But what happens if I change the limit to 20? This time we'll get just one page. Yeah, because 20 contains the whole 19 documents. So these are things that we will play with in the front end. There you have it. These are all the changes that we needed to make in order to allow us to filter by year, compute the number of documents per year, make the pagination controls work. Now we are ready to test this. Open the terminal, make sure to navigate to the front-end folder and run npm run serve. Click on this link and now you have the website. Let's start by searching. You can see that I immediately changed one thing. I removed the send query button, and now when you type, we will detect the characters that you are typing and we are immediately going to search. Because Elasticsearch is so quick, and because we are getting just 10 documents, this hardly takes 20-30 milliseconds, so it's very quick. And here are the buttons that we are added, or the controls. Here we have the pagination controls. So here you can see that we have 20 pages. So this is the max pages value. And now we can click on next to go to the second page or to go to the last page. If you want to go to the first page, you can do that. And here, look, we have 20 pages. If I set that the items per page is 20, this will drop by 2, and it did. So now we have just 10 pages and the max value is 50. So now we can click, you can scroll to see the images. When you are done, click to go back and keep going. Okay, now let's see. So we are searching here. Basically, we are typing S and we are getting something. But let's click on the all years drop down. You can see that in 2015, we have 21 documents. In 2024, we have 16. So let's click just on 2024. And you can see because we are using 50, we have just one page. But if I go to 10 items per page, we are going to get 2 because we have 16 documents in 2024. But what if you want to remove this filter? Just click on this X icon. And now you are back, and here you have all the documents. You can search like this, and sometimes if we don't find a document that matches the query, we will show this no results found text. And this is a problem with the tokenizer. Basically, Androm, this token does not exist in the index or in the inverse index, which means that we cannot map this to a document. So this causes a problem because basically we are using the default tokenizer, and this is a great thing. So in the next video, we'll be using a different tokenizer to solve this issue, and this will be wonderful. We will be using the things that we have seen in the analyzer video. But if I complete the query to Andromeda, Andromeda is something that exists in the document. So let's search. You can see that here we have a lot of documents with this term. This is why we get them. But for Androm or something like this, it doesn't exist. I hope that you find the video very interesting. You can see that I'm not diving deeper in the front end because what interests me is the back end. But you can find the code if you want to look at it. Everything is inside the front end folder. So go there and try to understand how this is working. I hope that you found this video instructive and informative. We will continue working on this final project. In the next one, as I told you, we will talk about tokenizers. See you next time.